So we saw how this got polarized when I brought in something negative near it, something negatively charged. What I do want you to pay attention to is that this object, although polarized, is still neutral. It still has as many positive charges as negative charges. It's just in an imbalanced state where they've kind of moved away from each other. But if I were to add up all the total charges, it'd still be neutral like it was before because no charges really came in or jumped out. And so recall that that is the um, the law of conservation of charge. Okay, can't charges just can't appear or disappear. Whatever is there is going to be there. The next thing I want you to look at is this is a picture of polarizing an atom. So imagine this was a centered nucleus here with a cloud of electrons. If I bring it near something negatively charged, the electrons will move towards the right, and this atom is now polarized, again, a charge imbalance. And then same thing over here, when I bring it near a positive charge, the opposite happens. The electrons kind of shift this way, and you can kind of see how this shape of this thing has become more ellipsoid, pulling that way, and then there it was pulling away. Another interesting thing, I have a balloon here that I charged probably by rubbing it to my hair and stripped off some electrons from my hair. And now this balloon sticks to the wall. And you might say, well, hey, hang on a second. This balloon is negatively charged. Negative charges get attracted to positive charges. So the wall is in positive charge. So why does the balloon stick to the wall? And the key here is polarization. If you look over here, when I bring this balloon near here, all the negative charges from it move away from this wall, which is really like an insulator, and it gets polarized. And so it has a charge imbalance where the negative charges have moved to this side and the positive charges are on that side. And so now the balloon has a reason to come closer to here because the positive guys are here and the negatives want to be near the positives. And so it's because it got polarized due to the presence of this balloon that the balloon sticks to the wall. The wall itself is not charged, it's just polarized. Okay? These charges may eventually leak over to the other side. That just depends on how much, and the balloon does eventually fall down. So there are three ways that we can charge something. If I have something and I want to make it positively charged or negatively charged, there are three different ways that I can do it. One is by friction, so I just rub two things together, and we'll look a little later at this thing called the triboelectric series, which basically is a series that tells you who prefers electrons more than the other guy. It's like a list of who does electrons want to go to versus the other ones, and you kind of make a list and say, hey, this guy's the highest in the list. He always takes electrons from everyone, and the next guy he's number two in the list. He's second best at taking electrons away. So um, based on what those two materials are that you're rubbing, one will take electrons away from the other. The other method is by contact, meaning I have something that's positively charged, I touch it to something else that's neutral. Um, Both are conductors. The electrons jump over to the other side to make sure that there's the same number of electrons in both of them, and they kind of distribute the extra charges. So one object has 10 extra charges and the other one is neutral, and you touch them together. When you separate them, they'll have five each because the five of those electrons ran over to the other side, saying, hey, let's get away from these too many electrons here. And then once they had five there, they had no reason to go there because you went over there, there'd be six over there. And then so they balance themselves out. The third method is induction. And this is where electrons the object is polarized and then shorted or got grounded, and one part of those charges are taken away. And we'll see how that is done as well. The charges are not coming from the item we brought it close to, but rather because of the grounding or the shorting that we do to take it off. So we're going to look at each one of these in detail, okay, to see how it happens. So here's friction, real simple. Okay, this video is going to end in about 5 seconds, and then I will continue on the next video looking and seeing how this